Our PLC rack now looks a little bit different to previous lessons because I've added in one of every single sort of I/O module, or the most common I/O modules. So running from the left, we have the CPU. Then we have a 16-way 24-volt digital input card. We have a 8-way 8-channel 24-volt DC output card, a 16-way 24-volt digital input, and also a 16-way 24-volt output card. This one here is a 32-way input card and also a 32-way output card, 16-way analog input card, 24-way analog input card, 8-way analog output card, and a 4-way input and output analog card. So one of the first things to notice, and it can be quite important for people who also get involved in the project panel design or the electrical specifications, is each one of these has a different width. So TIA Portal does show these widths, although obviously with no scaling, but you can see that this one is a skinny module, this one is a wider module, skinny, wide, wide, skinny, wide. It's not immediately obvious. You do have to sort of look harder than a glance, but they are true to form that some of the cards are wider than previous cards, than the skinnier cards. And if you roll back to previous Siemens models, such as the S7 300 series, most cards, if not all cards, were the same size. So you could base your panel size off of the space your CPU and PLC requires off of the amount of cards that you had installed. You can't do that with TIA Portal and the 1500 series. You need to actually work out how big your system's going to be. But from a configuration point of view, just like the CPU, if you click a card and come down to properties, you can have all of the properties here for the card that you have selected. I'm just going to pin this window so it doesn't keep opening and closing, and minimize this one. And I'll make this a little bit bigger so we can see what's going on. So with this card selected, which is our 16-way digital input card, we have a general section, module parameters, and input section. We also have I/O tags, system constants, and text. For now, we'll focus just on the general tab because that's the actual configuration of the system or this I/O card, and we'll worry about I/O tags and system constants and stuff later on in the course. So from here in your general tab, you can go ahead and give your I/O module a name like we did previously by clicking up here. That will set the name. If we come down, well, one of the other things that I'll show you quickly is if you expand this, you can only view the subsections, which, to be honest, in most cases is much easier than having to scroll through everything. So we have our project information, which we just changed the name in. Catalog information, this is useful if you need to go and tell somebody for a replacement part or to make sure you've got stock on the shelves and things like that. Identification and maintenance, something that is very, very often overlooked. By saying that this CPU is in this section of the plant, you might choose to put that in plant designation or location identifier. However you set it up is completely up to you. But by filling these bits of information in, for example, saying additional information, this input card is everything to do with chemical dosing. You set yourself up something that is referenceable so you can actually see this is what this card does without having to trawl through the software. And little things like that make a big difference when it needs to make a difference. So let's have a look at the module parameters. If I come to General here where we have Startup, Comparison preset to actual module. What this is doing is checking that the module is what we've got it configured to be. If we have a look at this drop down here, it says the comparison right now is from the CPU, so what the CPU has configured. And here we have startup CPU only if compatible, startup CPU even if mismatch. So right now, this from CPU depending on the configuration of your CPU and what you ask your CPU to do in the event of a mismatch or hardware component failure, the CPU will do that stuff. And we'll come on to that again later. There's going to be a lot of, we'll come on to that later. But right now, if it's selected from CPU and you put the wrong module in the wrong slot, a default brand new PLC would fault, saying that there was a hardware failure. If we have startup CPU only if compatible, then the PLC will raise a warning to say, this isn't what I have in my project. However, there isn't any conflicting problems from me using it. So I'll warn and continue. And this one is startup CPU, even if it's a complete mismatch. So I don't really recommend that one because I'm not even sure as to what your code or what the CPU or outputs might do if something was wrong. I would like to think if it's a completely, even though they say start the CPU even if mismatch, I would still like to think that it won't action any outputs or anything like that. I can't say that I've ever tried myself. Coming down to the DI configuration, this is your digital input configuration. You'll notice that all of these are grayed out. We can't actually edit any of these, and that's simply because there is no configuration requirement at this level for this type of module. What is the most important part of our setup is this section here, input 0 to 15. So if we come into general, again, nothing that we can actually change in here. It's simply pulling this information from the project information. If we come into inputs, general, here we designate what we want to do if the module has a failure. So input values with a module failure, we set the input value to 0 or false, and that is the default for one of these types of cards. However, you can say keep last value. So if something was a 1 or true before the failure, it will remain as a true during the module failure sort of scenario. And under typical conditions for a new installation or a new project setup, there's a good chance that your CPU is going to go into fault anyway and stop because that's how they come pre-configured. However, there are certain things that you can do to keep a CPU running, even if the I/O has a module failure, in which case it's important to know what that module will do with its inputs. Typically, I would keep this as set it to 0, and I would fault handle in my code if my code was to continue running on module failure. But most of the time, and most applications, if you have an input or an output card failure, you're going to want to stop anyway. So typically that's left like that. And finally, we have I/O addresses. Now, this is where you can set the raw memory address, so your I0.1, I0.2 that are used in your I/O tags. So people coming from a background where PLCs are more absolutely addressed rather than symbolically addressed should be quite familiar with the whole I for an input, 0.0 as your address, and then you have your values stored at that memory address. TIA Portal is no different. Everything does have an address when working with inputs and outputs. However, you can change that address at a card level, sometimes even further than a card level for each of the I/O cards that you have. So, for example, I might say I want to set this at 100. And if I go and have a look at the I/O tags now, they start at 100, and all of the other ones are offset from the original start address at 100. Setting that back to 0, you can see that the end address goes back to 1.7. Now, typically, I don't get too caught up on this. I let TIA Portal do what it needs to do. I'm going to address everything symbolically anyway later on, so I don't really need to concern myself too much with what this start and end address are. It's only really when you get into wanting to bulk move information, which is done at a pointer. And if you're not using symbols for pointers either, then yes, you need to know the memory address. But as we go through the course, you'll understand more and more why it's not such a big deal anymore. Down here, you can tie the input acquisition to a organization block. So it comes as automatic update, which I would recommend you leave it as. It's only really for special cases where you want to poll an input card and say, I only want to get your latest value when this organization block runs. I can't think of a scenario off the top of my head where you might need to do that, because personally, I would move the information into a buffer and only update the buffer when I actually need to have the latest information, and I would poll the IO card all the time. And here you have the same thing for process image. And again, I would leave process images alone and have them on automatic update. We are going to move the information into data blocks anyway. Again, people who've used Tier Portal before might question why I'm not just using the tag, but as we go through the course, you'll see why. It allows us to manipulate data and work with things in a much more structured and defined way than just using the tag coming straight from the hardware. So let's have a look at a digital output card now. You'll see that we have the same sort of setup. If I come into general, in fact, all of this is identical. There's no difference in this section. Module parameters, we have a few different ones. We've seen this startup and what to do with startup. It's the same drop down and values that you can set there. If we come into channel template, this is a little bit different because what this card physically does is different to an input card. So you have some diagnostics that you can set here, and what this will do is allow you to check diagnostics in the online diagnostics when something happens. It will also trigger particular OBs that you can set up to run routines if something happens that requires diagnostics. So personally, these aren't used by me, but my applications don't require them. They might be used by yourselves. If you hover over it and click this button here, it tells you crudely, but it's more information than just what no supply voltage means, but it does tell you what will happen. If it's selected, short circuit to ground is fairly obvious. So select this checkbox if you want to enable the diagnostics for short circuit of the actuator supplied to ground. That's simply you have an output directly connected to ground. Reaction to CPU stop. This is an important one because we're talking about outputs now, and outputs are controlling physical devices. So the default is shut down. And I wish they were clearer with this. Shut down means turn off, false. We're sending a false out of our output card, which means no voltage leaving the output card. That's what shutdown means. We have keep last known value, which can be important for particular applications where if something goes wrong and the PLC stops, you need to maintain your output because it's holding something up or it's got a gripper arm like closed around an object or something like that. So it could be that you genuinely do need to keep last value. You do need to be careful about grouping outputs if that's the case, because we'll check this, but I don't believe you can set the output response per channel. So, and then you have output substitute value 1, which is a really roundabout way of saying turn it on. So turn it off, don't do anything and stay as you were, turn it on. If we come down to the DQ configuration, in here we have our digital output configuration, which looks very similar to the input module that we looked at earlier, but we can actually set some stuff in here. So for example, this here, our value status, if this is deselected, so let me just turn that off again and then come into IO tags, you see that we have 8 outputs, which is what we expect for an 8-way output card. If I come back to this and click value status, we now have 8 inputs. And obviously we're not wiring those inputs in, but what we're doing is checking that when we turn this output on, so Q0.0, we expect the output card to give us an input back to say it's turned on. And that allows us to do some sort of qualifying checks to make sure that the output card has actually listened to our request and is communicative, is updated, and things like that. So it's not quite safety, but I guess it's there for a safety check, but it's not a safety module. Typically, I don't have that turned on. It's usually fairly obvious in most applications. If you turn something on, you'd have some other in-field way of reading back that it's operational. And anything that you don't typically wouldn't matter or cause an issue. Here we have copy of module for shared device. Well, we don't have any shared devices right now. And you can turn on pulse width modulation for certain applications or certain cards, and that creates a PWM signal. But I don't actually believe that we can set that. We can turn it on as a feature, but you need to set it per channel, I believe, and I don't think this card can do that anyway. So again, coming down into our outputs 0 to 7, this is probably the most important tab. If we go to general, you get the same thing as last time. It's just the project information again, and you can't edit it here anyway. And if we come to the configuration overview, we have diagnostics. This is slightly different because we've already seen diagnostics. If you remember, we saw the diagnostics or this selection. These here, no supply voltage, short circuit to ground. We've already seen these options in the DQ configuration, not DQ, sorry. Where was it? In the output channel template here. So if I tick that one saying no supply voltage, and then I come to our diagnostics, you'll see that these are all ticked and I can't turn them off. And that's because they are coming from the template. So that's this template here, short circuit to ground, come back to diagnostics. Now short circuit to ground is turned on, but I can say, I don't want to come from the template. I want this particular one to be manual, and I don't need no supply voltage for this one, and I don't need the short circuit to ground. So you do have a bit more flexibility. Not all cards can do this, and the things that are listed in here may vary from card to card. If we come to the output parameters, you do have the same thing here. Actually, I said earlier that I didn't think you could set individual channels for reaction to CPU stop, but you can. So again, from template, notice that this one was already manual. That's an important thing to notice as well, because now I've put that from template. If I go back to this diagnostics, this is from template as well. So if you'd actually set everything in your template at this point here to say, well, I want to keep everything turned on, or I want it to be keep last value, and then you came into diagnostics here and said, well, I don't need short circuit for this one, go to manual and turn that off. When you come into output parameters, it hasn't changed the value, but this can be selected to something different. And yeah, so now what would happen is only channel 0 would shut down. If we come to our outputs, we now have individual channels here where we can set up pretty much exactly the same information that we just set up in the output parameters. Again, Paul will put in the same information in 2 different places. For example, I turn that no supply voltage off now, come back to the output parameters, the diagnostics, and it's off now. Turn up these 2 back on, come back here, and now they're back on. I'm not sure why Siemens decide to do this sort of thing. It just becomes confusing, but what you see in this configuration overview and what you see in these outputs are essentially the same thing. And again, coming down to I/O addresses, you'll see that TIA Portal's already assigned 27, and that will be because of how it manages its memory. You can try and change it to something else, say 0. And if it's the address is available, it will assign it. If it's not available, it won't assign it. Personally, I would try to set all of the values as low as possible, so there's no gaps and consistency throughout the addressing, and the organization block and process images are exactly the same. So let's have a look at a split card. For example, this one, which is our digital input and output, I believe. This is digital input and output. And again, general, exactly the same. Module parameters, DI, DQ, the same. Although you'll notice that we can't set a value status for this one, even though it's got the digital outputs. And that's because we're already using 64 channels or 64 bits in the I/O tags, and there isn't enough room left in the module for us to carry another additional 32 bits of information. So that option is unavailable for this card. If you come to input and output this time, 0 to 31, come to general, same thing, project information only. Here we have inputs, so what to do on module failure for the inputs, and I/O addresses. Notice that we don't have the same functionality to say what we want to do for outputs. So when we look at outputs for this one, we can assign things like what do we want to do in the event of a CPU stop. But when we come to the digital input and output card, we don't have that functionality. And this is where different cards have completely different functionality, and it's important to understand what the functionality is before you add things into your project. If we look at the 16-way digital input output card, which is this one here, if we have the same sort of setup, again, we are unable to set the outputs to stay on, keep their last value. They will shut down as a result of a CPU stop. And let's have a look at analogs. So analog inputs, same on the general. Module parameters, we have a channel template for inputs. So detection for overflow, which is anything over its maximum input range. Underflow, anything under its minimum input range. And a common mode error, which I can't remember what that is. It's something to do with the voltage. But you can also set up your channel template. So what are the majority inputs for your card set up to be? So for example, we might say 2-wire transducer, and this card can only do 4 to 20 for 2-wire. If we had a 4-wire transducer, it can do 0 to 20, 4 to 20, or plus or minus 20, so minus 20 to positive 20. So we can set this up as this 4-wire 4 to 20. Your analog input configuration, again, none of this is applicable. Come down to our configuration overview and diagnostics. We can say from template or manual again. Input parameters, we might say all of them are 4-wire except for channel 1, which is a 2-wire 4 to 20, and we need smoothing on this one, which smooths out the signal. So if you've got a bouncy signal, it will average it over a period of time, and that's what the PLC sees. And again, although we have this configuration overview, you can go and view exactly the same information at a per channel level. You do have some additional information on this one, which is your hardware interrupts. So you can cause a hardware interrupt in your program, which runs a different subsection of code. And you just enable that, give it an event name, which comes through in the diagnostics. And then you choose your hardware interrupt. We don't have one created yet, but you create one and you set what the limit is in order for that hardware interrupt event to be raised. But we'll cover that sort of stuff later on as well. And then your I/O addresses. And just to wrap things up, I'm moving through it quickly. In our outputs, we have exactly the same thing. Channel template, an AQ configuration. There is a value status for this. If I tick that and go to I/O tags, you have your booleans to say whether what you're outputting is registered as correct, and you'd have a true in here. And we also have our configuration overview, where we can set from template for our outputs and things like that. we have our actual outputs. Again, this particular card has got heart, so we can configure things such as our preamble and repetitions for our heart network. I'm not going to go into what heart is. And we have our I/O addresses. And because this is a heart device, down here we also have some information about our heart settings. And that's pretty much it for setting up I/O modules. I appreciate there's an awful lot to take in there, but I'd encourage you to go and add some things some modules into your rack and just have a look at the configuration and play about with what that might change with your hardware. Especially useful if you actually have the hardware with you.